Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Topic for today, potassium permanganate, and we shall be doing its preparation, properties and uses. Potassium permanganate is a very common chemical which you would have used in the laboratory for a number of tests. So you know it as an analytical reagent, right? It is a very good antibacterial as well as antifungal agent. Hence it is used for cleaning wounds, for any type of skin infections. Hence it has medicinal uses as well. A pinch of potassium permanganate added to water, which is used for drinking purposes, helps to clear out the bacteria as well. When you get injured, you would have seen a red liquid being applied to your injury many a times, and that is what is commonly known as the lal dawai, right? It is also called Condy's crystals. Interestingly, it is also called as the chameleon mineral. So chameleon means something which changes its color, right? So the same behavior is observed in the case of potassium permanganate, hence the name. It is a very good oxidizing agent, just like potassium dichromate. So if you've gone through the lesson of potassium dichromate, you will find this topic very easy to sail through, because we shall be talking about a lot of properties based on the partial equation method. Can you list down some other uses of potassium permanganate for me, please? That's a question for today. We observe the behavior of permanganate ions. Permanganate ions, potassium permanganate is dark purple in color, KMnO4. You've used it in the laboratory. Just try to close your eyes and go back to the solution that you deal with in the laboratory. You'll remember that it is a dark purplish, pinkish color liquid, right? The structure of permanganate ions. Mn, the 4 oxygen atoms attached to it in a tetrahedral arrangement, negative charge, purple in color. Add an alkali, it turns green in color. Why does it turn green in color? Because the permanganate ion changes to manganate MnO4 to negative. That means it has an oxidation state or a charge of -2. To the manganate, you add an acid, it turns back to permanganate. So we have, depending on the pH of the solution, the color will vary. And that is what we use in order to identify gases or substances in the laboratory. Can you remember one gas which you used to identify using potassium permanganate? It actually changes colorless, right? Go back to the laboratory, think about it, go back in the sense, close your eyes, think about it, and you will get your answer. If you've noted this down, I can then go on to the next screen where we shall be talking about, let's see, preparation of properties. What do you want to do first? Please make a note of this so you have your notes ready for offline reference. It gets a bit boring doing the same thing in the again and again. So I've reversed the order. What we are doing now is the properties of potassium permanganate. And here I have the flow chart that you were looking for. First property, solubility. Again, sparingly soluble in cold water but readily soluble in hot water, just like potassium dichromate. Deep purple black crystals. Again, I've tried to put some color so that it's easier to remember. They decompose in the presence of light. That is why potassium permanganate is stored in dark colored bottles, so that they do not get decomposed. Chemical properties. Potassium permanganate on heating changes to potassium manganate. Potassium permanganate on treating with an alkali, just now we did, changes to potassium manganate. MnO4, 2 negative. The most important over here is the behavior of potassium permanganate as an oxidizing agent in acidic medium, in weakly basic medium or neutral medium. In the acidic medium, we have these set of various reactions: ferrous to ferric, iodides to iodine, oxalic acid to carbon dioxide, sulfur dioxide to sulfuric acid, H2S to sulfur, HX, that is the hydrogen halides, HCl, HBr, converted to the halogen, nitrides to nitrates. Alcohols are oxidized to aldehydes, and some aldehydes can further be oxidized to carboxylic acids. Now those details you will do in organic chemistry. Oxidizing agent in weakly basic or neutral medium. Iodides to iodates. Please see the difference. Iodide is getting converted to iodine, whereas in a basic medium or neutral medium it is getting converted into iodates. Thiosulfates to sulfate and sulfur. Hydrogen sulfide, just like over here, converted to sulfur. MnSO4, manganese sulfate, converted to manganese dioxide. Hydrogen peroxide oxidized to water. Right? Now, I would like to give you a hint over here. When dealing with organic chemistry also, you can draw flowcharts like this, and they come in very, very handy to remember the vast number of organic reactions that we have to keep in mind for completing our curriculum. I will post a link in this video and other videos as well of my website, where I have put these flowcharts for organic compounds as well, which have been found to be very, very useful by the students. So please feel free to download them, but at the same time, if you can spare some time, please draw those flowcharts yourself, maybe in colored pens, just like this, dividing each of the property on the basis of its color, and see the magic happening. Trust me, the magic will happen. You will be able to remember the reactions better. You will enjoy also learning chemistry is in an easy and fun way. Right? Now, how am I going to use this flowchart? If you've seen the video on potassium dichromate, you will know. If you are new to the channel, here we go. Using this flowchart. So what I've got over here, KMnO4 on heating changes into K2MnO4, MnO2 and oxygen. Simple. Now what is left for you to do is to balance these equations. Unless you balance, inorganic chemistry has no relevance. So according to you, you would have written the correct equation, but if you do not balance, you do not get full marks. And anyway, from science point of view also, you are not doing justice, because you are not showing it as obeying the law of conservation of mass. Second equation, KMnO4 plus alkali. So what we've got over here is KMnO4 plus KOH gives us K2MnO4 plus water plus oxygen, which is a gas. Simple. Can you balance this equation? Very good. Let me now teach you the partial equations that you will write for the oxidizing behavior of KMnO4 in an acidic solution. I hope you've got your pen and paper in hand. There is no point, absolutely nothing achieved in just watching this video. No purpose will be served unless you have a pen and paper in your hand and you are writing down these equations. And if you've written down these equations alongside while watching this video, half of your work is done, boss. You don't have to do anything after this. You just have to, probably brush through the flowchart once again, And that's it, your topic is covered. So get a pen and paper while we write the equations. Now I have not rubbed out the entire flow chart, teaching you the oxidizing behavior of KMnO4 in an acidic solution. KMnO4 plus H2SO4 gives you K2SO4, manganese sulfate, water and nascent oxygen. Oxygen generated during the course of a reaction. Now, let's see, we're taking the first one, ferrous to ferric. So we take a ferrous salt, it's an acidic medium, H2SO4 plus nascent oxygen gives you Fe2SO4 whole thrice. Correct? Now this is not our final equation. We will get the final equation by adding the two of them. But before we go on to do that, let us balance them. So potassium, we've got 2 over here, manganese is 2, so leaves me with 2 and 1, 3 sulfate. So we've got 3 over here, 3 times 2 is 6, 3 times 2 is 6. Now let us see, are we balanced? 4 times 2 is 8, 12. 4 times 3, 12 plus 8 gives me 20. You can always pause the video and try to balance it yourself rather than waiting for me to give you the answer. It will do you good. Here let's see, 4 times 2, 8 plus 4, 12, 13, 14, 15. Here it's 20, here it's 15. So we have 5 nascent oxygen over here. Let us now balance the second equation as well. So we've got 2 iron. Let me remove this so as to avoid confusion. 2 iron, 2 iron. Sulfate is 2 plus 1, 3, 2 plus 1, 3 over here. And is the oxygen balanced? 4 times 2. Go ahead. No, oxygen is not balanced. So how do we go about it? But there is no hydrogen on the right hand side, right? So I was missing one of the compounds, and that is H2O, correct? So we've got 2 hydrogen, oxygen over here, and this balances. Now we've got 5 nascent oxygen being released, so 5 will be used up over here. I multiply the second equation by 5. Since we are already through with this, let me rub it out to give us space to get the final equation. Now 5 nascent oxygen being generated, 5 nascent oxygen being used up. Finish. Now let's add the 2 equations. What do we get? 2 KMnO4. So let me first take the components from the first equation. Now I've got 3 H2SO4 in the first equation being used up and 5 in the second again on the reactant side. So 5 plus 3 makes it 8. 8 H2SO4. Any other ingredient? Yes, we've got 5 times 2 is 10 FeSO4 gives us. We've got K2SO4 plus twice MnSO4 plus 5 Fe2SO4 whole thrice plus. Now, water 3 as products on the right hand side in the first equation and 5 as products on in the second equation gives us a total of 5 plus 3, 8 H2O, right? So let us see if our final equation is correct. So 2 potassium, 2 potassium, 2 manganese, 2 manganese. Of the sulfate we've got 8 plus 10, 18. So we've got 5 times 3, 15, 16, 17 and 18 sulfate. Hydrogen 8 times 2, 16. Hydrogen 8 times 2, 16. Iron 10, iron 10. Well done. Are you able to relate to this? First equation will now remain the same. Do the second equation. Second one, Ki. That means conversion of iodides to iodine. Instead of FeSO4, put Ki over here. So Ki plus H2SO4 plus nascent oxygen will give you K2SO4 plus, very good, water is definitely there. And what will be the third ingredient? Yes, it's iodine. Correct? So can you try and write the equation for the second one, Ki converted to iodine? Pause the video, don't look for solution, pause it, try it. Then only there is a point in watching this video, otherwise there are hundreds of videos. So you want to tally whether you got it right or not? What I've done over here is on the board I have left the original values in black. The red ones are the new values. So if you notice, everything else remains the same. What changes is potassium iodide and your product over here, iodine, and of course this, K2SO4 is also a product which is new. 5 nascent oxygen being generated, 5 nascent oxygen have to be used up. So you have 2 KMnO4. This is just like the original. So let me put it in black only. This doesn't change. 3 and 5. So we have 8 H2SO4. This is also like our first equation. Go on to now. What is there in the reactant? You've got 5 times 2 is 10 Ki. Correct? Nascent oxygen being generated, nascent oxygen being used up, finishes off. K2SO4, 5 plus 1 gives me a 6 K2SO4. MnSO4 twice. Water, 5 plus 3 gives me an 8. What about iodine? 5 I2. Right? Let's check, are we on the right track or not? 10 plus 2, 12 potassium, 6 times 2, 12. Manganese 2, oxygen 4 times 2, 8. Oxygen we'll have 8. Sulfate 8, sulfate we've got 6 plus 2, 8. Iodine 10, we've got iodine 10. Hydrogen 16, we've got hydrogen 16. So simple, right? Now would you like to try the next one yourself, where we've got the oxalic acid? I'll give you the second equation for this so that there is no confusion. For oxalic acid, the first equation remains the same. The second one, this oxalic acid gets oxidized to carbon dioxide and water. Yes, same like potassium dichromate. Coming to, so we've done the second one, we've done the third one. What did we have as the fourth one? Was sulfur dioxide to sulfuric acid. So the fourth one. Fourth one is sulfur dioxide with nascent oxygen actually gets converted to sulfur trioxide. And that sulfur trioxide dissolves in the water to give you H2SO4. This is how it is. Now instead of writing it as 2 equations, what we do is make life a little easier for the students, and we write it simply as the second equation, H2SO4. Go ahead, keep on writing. There is no point in just listening to this video unless you do these equations yourself. Keep writing. Believe me, by the end of this video, you will be thorough with this topic if you write these equations at least once with your hand. Then was H2S2 sulfur, that is easy. So because you know it from your, so water plus sulfur, yes, this is the same as potassium dichromate. Then it was HCl to chlorine or hydrogen halides. So it was HCl plus nascent oxygen gives you H2O plus Cl2. You can also take HBr or HI, anything over here. Then NaNO2 to NaNO3. You want me to write that down? It's pretty simple, right? NaNO2 plus nascent oxygen. NaNO3. Correct? Are we done with this? Do we go on to the oxidizing behavior of KMnO4 in weakly basic or neutral media? Please go ahead with the video only after you have written down the equations for oxidizing nature of potassium permanganate in an acidic medium. You will think that I am unnecessarily dragging the video by saying the same thing again and again, but I know. I have been a student myself and the general tendency is, oh, this is easy, it's okay. Let me go ahead. It's not like that. Please, for my sake, just try it. Okay, what is the next step we are doing? I'm not talking about basic medium. If you notice, I've converted the molecular equation into an ionic equation, and that is what I'm going to teach you now. I've noticed that at quite a few places they write the equation as an ionic equation. How to convert a molecular equation into an ionic equation? Let's see that. This molecular equation, I have written it, split it. So I've got 2 potassium ions and 10 potassium ions, gives me a total of 12 potassium ions. 2 permanganate ions, because MnO4 negative is a single entity. 8 times 2, 16H positive. Then we've got 8 sulfate ions. 10 potassium ions already accounted for. 10 iodide ions, right? So the left hand side I have written in red pen. Do the right side. 6 times 2, 12 potassium. 6 sulfate and 2 sulfate. Total of 8 sulfate ions. 2 manganese ions. Mn2 positive. I2 is a molecule, so we don't write it in the ionic form. Same way water will be a molecule. It is not ionizing. It's a product, so we don't write it in the ionic form. What is the next step for you to do is to cancel out the common ions or the ions which are not undergoing any change. 12K positive, 12K positive. Finish. Anything else that we can remove? 8 sulfate and 8 sulfate. Clear? Anything else that we can remove? No. So overall this equation is 2MnO4 negative plus 16H positive plus 10I negative gives us 2 Mn2 positive plus 5 iodine plus 8 H2O. Let's see if it is balanced or not. Minus 2 plus 16 minus 10 gives us a total of 4 positive. 2 times 2, 4. Clear? 2 manganese, 2 manganese. 4 times 2, 8. 8. Hydrogen 16, hydrogen 16. 10 iodide, 10 iodine. Right? As simple as that. I love the smile on your face, and that is what this channel is about. Now, you can just convert any molecular equation into an ionic equation. It will not take time. It will take time the first time you try it. After that, after the third equation, you will be ready to teach this topic to any of your classmates. So let's now go on to oxidizing behavior in weakly basic or neutral medium. Oxidation in weakly basic or neutral medium. I'm first taking up the oxidation in weakly basic medium. KMnO4 plus KOH gives you K2MnO4. Now this particular reaction we've done in the properties as well. In an alkaline medium, permanganate changes to manganate, releasing nascent oxygen over here. The reaction does not stop at this. The manganate further gets converted to MnO2, KOH, and again releasing nascent oxygen. So before we go on to write the second equation of the substance it is oxidizing, we need to club them. Because K2MnO4 is being generated, K2MnO4 is being used up over here. And we need to balance the equations. 2 potassium, 2 potassium, 1 manganese, 4 plus 1, 5 oxygen, 4 plus 1 plus, so 5 plus 1, 6 oxygen, right? So we need to balance the oxygen and we need to balance the hydrogen as well. So I've got 2 plus 1, 3 potassium now. So let us put 2 over here. Makes me put a 2 over here as well. Should we check the oxygen? 4 times 2, 8 plus 2, 10. 4 times 2, 8, 9, 10. Hydrogen 2, manganese 2, potassium 4. Our first equation is balanced. Let's balance the second equation as well. So 2 potassium, I've got only 1 potassium over here, 2. Manganese, oxygen 4 plus 1, 5, oxygen 2 plus 2, 4 and 1, 5. Hydrogen 2. Our equation is balanced over here as well. Now what do we need to do? We need to add up the two equations to give us the final equation which we are going to use. 2K2MnO4 is being generated. So in order to equalize, I will multiply the second equation also by 2. What is the next step? You cancel out the common ion, the common or the product and the reactant. So generated, reused up. Water and 2 water over here. KOH, 2 KOH, 4 KOH. So let's start adding them up in order to remove the confusion. So we've got 2 KMnO4 plus 2 KOH being used over here, 2 times 2, 4 KOH being generated. So end result is my KOH will be product or reactant. Very good. It will be product. So 2 KOH will be the product. Water. 1 water being generated over, 2 water being generated over here, used up and 1 water being generated. So overall, how many water molecules are being used up? 1, because 2 reactant, 1 product. MnO2, 2 MnO2. What about the nascent oxygen? Because in both the reactions, it is a product. So 2 nascent oxygen plus 1 nascent oxygen gives me 3 nascent oxygen. Let us see, is our equation complete? 2 potassium, 2 manganese. 4 times 2, 8 and 1, 9. 2 times 2, 4, 5, 6, 7, 8, 9. Right? Hydrogen 2. We started with an alkaline medium, but in the end equation, we are only getting water as one of the reactants. So KMnO4 plus water gives you MnO2 plus KOH plus 3 nascent oxygen. That's our first equation which we are going to use in the partial equation method. So that makes our task easy, right? Because this is the partial equation which I am going to use whether the solution is weakly basic or neutral, because it is the same as in the water. So we did iodides to iodate. So let me write the second equation over here for this. So Ki plus nascent oxygen gives you iodate. So KiO3. Balance this equation. You've got 3 nascent oxygen over here. Add the 2 equations. 3 nascent oxygen being released, 3 nascent oxygen being used up. We cancel it on the left and right hand side. And we add the 2 equations. So we've got 2 KMnO4 plus water plus Ki gives you 2MnO2 plus KiO3 plus 2KOH. Is it easy or not? Still confusing? Okay, let me take one more example, but make sure that you write this equation yourself. Let us see one more. Which one do you want to take? Hydrogen peroxide or thiosulfate? Let's do the thiosulfate one. Have you noted this down? Should I rub it out? Sodium thiosulfate, oxidation of sodium thiosulfate with alkaline KMnO4 or neutral KMnO4. Our first equation remains the same as it is, as we have derived. Sodium thiosulfate plus KOH, it's an alkaline medium, nascent oxygen, and we'll get sodium sulfate, K2SO4 and water. Before we go on to add the two equations to give us the final equation, what we need to do is, yes, balance the second equation. So let's go on to balance the second equation. 2 sodium, 2 sodium. Sulfur 2, sulfur 2. Potassium 2 over here. We'll put 2 potassium over here. Then we've got oxygen 3, 4, 5 and 1, 6. Right here, oxygen is 4 and 4, 8 and 1, 9. So we've got, I need to put 4 more oxygen over here. Why 4? 3, 4, 5, 5 and 4 makes it 9. Right? Now, if you notice, 3 nascent oxygen as product and 4 as reactant. So I need 4 nascent oxygen in order to carry out the reaction. So we need to equalize the coefficients in the two equations. We multiply this equation by 4 and the second equation by 3. So we will have 12 nascent oxygen as product and 12 nascent oxygen as reactant. Cancel out the common ones. You've got 4 times 2, 8 KOH and 3 times 2, 6 KOH on the product side. Okay, let me make it easy first. 4 times 2, 8 KMnO4 plus 3 Na2S2O3 plus, let us see, will there be water on the left hand side or not? There's 4 water here and 3 water there. So we will have 1 water. Gives us 4 times 2, 8 MnO2 plus 4 times 2, 8 KOH and 3 times 2, 6 KOH. So we will have overall 2 KOH on the product side, 3 Na2SO4 and 3 K2SO4. Na2SO4 and 3 K2SO4 gives us our final equation. Now, to convert a molecular equation into an ionic equation, I have already taught you. But this isn't it making things more complicated? You want the things to be in still easier way, right? Okay, let me give you the trick. Now, if you notice over here in alkaline medium, MnO4 negative is turning to MnO2. MnO4 negative converting to MnO2, right? S2O3, thiosulfate ions, getting converted into sulfate ions. SO4 to negative, be it sodium sulfate, be it potassium sulfate, it is getting converted into this. This is my basic ionic equation that I have got. Potassium is balanced on both sides, we are not talking about it. Go back to your lesson on balancing of redox reactions and simply balance this equation by any of the two methods that you have learned. Either the oxidation number or the half equation method. That's all that you have to do. Yes, it solves a lot of problems because most of the places you will find the ionic equation. So let me give you a quick tip on writing ionic equation in acidic as well as basic medium. So you notice over here the pH of the medium plays a great role in defining the products of any reaction. So for example, if it's an alkaline medium, the iodide gets converted into iodate. But if it's an acidic medium, the iodide gets converted into iodine. If you want to learn only how to write the ionic equation, you don't want to get into the nitty-gritty of writing the molecular equation and then converting it into ionic, the basic equation in the alkaline or neutral medium remains as MnO4 negative changes to MnO2. So if you are talking about I negative changing to IO3 negative, put the two parts together, left hand side, right hand side, and then balance the equation by any of the two methods, oxidation number method or the half equation method. You want to show thiosulfate. So MnO4 negative plus H2O3 2 negative gives MnO2 plus SO4 2 negative. You want to show the reaction of the conversion of manganese salts to MnO2, club these two together and balance. So something you will have to learn. You just can't make an escape. But if you memorize, that's entirely your choice. Acidic medium, MnO4 negative changes to Mn2 positive. So iodide to iodine, sulfide to sulfur. So if you want to show this reaction, club the two parts. You want to show the reaction with sulfide ion, club these two and then balance the equations. Remember to balance using the acidic medium concept. Remember, it's an alkaline medium concept, right? Go ahead and practice these equations. And we now go on to the preparation of potassium permanganate. Let us now do the preparation of potassium permanganate. The ore from which potassium permanganate is extracted is pyrolusite, which is mainly manganese dioxide, MnO2. This is fused in a reverberatory furnace with alkaline agents like potassium hydroxide or potassium carbonate, oxidizing agents like potassium nitrate or potassium chlorate. This gives us a green mass of K2MnO4, that is potassium manganate. Correct? What is the role played by potassium nitrate or potassium chlorate? As we said, these are oxidizing agents. They are going to release the oxygen. This equation you can either write as KNO3 on heating gives you KNO2 plus nascent oxygen, or you can also write it as plus O2, right? KClO3 will give you KCl plus O2 because you are more familiar with these equations. MnO2 in the presence of an alkali undergoes oxidation, forms K2MnO4 plus water, and there's no carbon dioxide. Carbon dioxide you'll get if you are using K2CO3. So what we've got over here is if I'm using KOH as the alkali, these are the products. If on the other hand I am using K2CO3 as the alkali, then in that case we get K2MnO4 plus carbon dioxide as the byproduct. I've written the reaction with nascent oxygen. You can also write it with O2, but the most important thing is in whatever form you write, make sure that you balance the equations in order to make sense of the equation. What's the second step? It is called disproportionation. Disproportionation is wherein what is happening in the process of disproportionation is the K2MnO4 here is in an acidic medium converted to KMnO4. Can you calculate the oxidation number of manganese over here for me? Please remember it's MnO4 2 negative. So we have X minus 8 equals minus 2. So we will have X as 6. Oxidation number of manganese is 6. What is the oxidation state of manganese in KMnO4? Right. It is 7. What is the oxidation state of manganese in MnO2? Again calculated. So this is X minus 4 equals 0. So the oxidation state of manganese over here is plus 4. Manganese in K2MnO4 from plus 6 state it is changing to plus 7 state. One oxidation state higher. From plus 6 it is changing to plus 4. A step lower. Two steps lower. So there is oxidation and reduction of the same element which is taking place within the same reaction. This is what we mean by disproportionation, wherein the element changes from one state to another which is higher, and a state which is lower in oxidation number is called as a disproportionation reaction. So in other words, what is happening is it's the same substance undergoing oxidation as well as reduction within the same reaction. Can you recall other reactions where you have studied disproportionation? Do you remember NaOH plus Cl2? You have two reactions of these, cold and dilute, hot and concentrated. You have also done disproportionation reactions in organic chemistry. Can you recall any of those? Very good. If you can't, time to revise maybe. Correct? Now if you've noted down these, we have one more method to carry out the preparation. But make sure that you balance the equations. K2MnO4 plus HCl is giving us KMnO4, MnO2 and water. The reaction is taking place in the presence of agents like chlorine gas, ozone or carbon dioxide, which are going to provide the relevant medium, the acidic medium or the neutral medium. Second preparation is, we are talking about the laboratory preparation where we have to prepare it on a small scale. This is done by oxidation of Mn2 positive salts, that is manganese 2 salts, using peroxo disulfate. Now here what I have done is I have written partial ionic equations and left it for you to balance it. Balance these equations using the redox reaction method, right? Because we are talking about oxidation reduction over here. So try balancing this equation just like how it has been taught, either by oxidation number method or by half equation method. So we will get 2, 5. There's a component of water over here and there's a component of H positive over here. Good. If you've got this right. Yes. 8. So this gives you a 2 over here. And sulfate, how many are there? 10. What about hydrogen? I'm not going into the details of it. I would like you to balance it yourself in order to get the final equation. Preparation, commercial. Whenever we talk about commercial preparation, we ensure that we use a method which is profitable as well as easy, right? It should be convenient. It should not be a very complex method. That is why we are using the word commercial preparation. Commercial preparation is nothing but an extension of the first method that we use to prepare KMnO4. Only thing is, what we are using over here is MnO2, KOH, and we are using either air, which has a free supply of oxygen, or KNO3. So we are using alkali. We are using oxygen or KNO3 for oxidation, right? So what we are doing over here is we are doing alkaline oxidation of MnO2 and we are fusing the substances. That means we are heating them at high temperature. So alkaline oxidation of MnO2 is our process, which many students find, quite intimidating. What is this big word? This is it, right? You may also add fusion over here. Once you've got K2MnO4, now earlier what did we use? We used acidic medium to bring about disproportionation. Now considering the efficacy of the process, what do is we carry out the same process, but what we are doing is we are carrying out the electrolytic oxidation in an alcoholic solution in order to convert potassium manganate to potassium permanganate. Have you written down these equations? That also brings us to the end of the lesson D and F block elements according to some curricula. There could be other compounds. If you let me know, I can cover it in my videos, and we shall start a new topic after this. Stay tuned, stay connected, stay calm. See you in the next video. Happy studying to all of you.